Hello good people, I'm going to talk about square and cubic unit conversions. A wall with an area of 8.45 square meters will be painted a shade of slate blue. Why slate blue? Well, because lime green clashes with the color of my eyes. It takes 6.5 microliters to paint a single square centimeter. How many liters of paint are needed to paint the entire wall? In order to solve this problem, I will need to perform unit conversions. The wall is in square meters, and the question is asking me about liters of paint. This means that I will need to convert these microliters per square centimeter to liters per square meter. I'm going to follow a familiar process. I will write what was given to me as a fraction and multiply it by two conversion factors that will initially be blank. I will use the units of the expected result to fill the conversion factors. When it comes to the volume conversion factor, liter is the bigger unit, and so I will place a 1 next to it. Using the values for the unit prefixes, I can say that 1 liter is the same as 1 million microliters. In case of the conversion factor for area, square meter is bigger. And now I need to ask myself, how many square centimeters in a square meter? A common pitfall is to say 100. After all, there are 100 centimeters in a single meter. However, we are not dealing with centimeters and meters. We are dealing with square centimeters and square meters. So let me explore that a bit. Here is a square that is 1 meter on each side. The area of this square is 1 meter multiplied by 1 meter. And that will give me 1 square meter. Now each meter is the same as 100 centimeters. And so I could say that the area of this square is 100 centimeters multiplied by 100 centimeters. And that will give me 10,000 square centimeters. This means that 1 square meter is the same as 10,000 square centimeters. And that is the value that will go up here in my conversion factor. Now that the conversion factors are complete, I can multiply the fractions. And that will give me 65,000 liters over 1 million square meters. Dividing these two values will give me 0.065 liters per square meter. To answer the question of how many liters I will need, I can take this value and multiply it by the area of the wall. So that will be 0.065 liters per square meter multiplied by 8.45 square meters. According to my calculator, that is 0.54925 or 0.55 liters when rounded to two significant figures. So when dealing with square units, we cannot use the values for the prefixes as they are given by the unit scale. A similar situation arises when we are dealing with cubic units. In this example, we have been given the density of a particular chocolate as 1,320 kilograms per cubic meter. How many grams of chocolate are there in a block that occupies 217 cubic centimeters? To answer the question, we need to perform a unit conversion from kilograms per cubic meter to grams per cubic centimeter. The process is the same as always. Write what has been given as a fraction, multiply by two conversion factors because we have two different units, and then use the units of the result to guide the conversion factors. Let me do that quickly. The common pitfall is to say that 1 cubic meter is the same as 100 cubic centimeters. This cube is 1 meter on each side. So the volume of the cube would be 1 meter multiplied by 1 meter multiplied by 1 meter. And that would give 1 cubic meter. However, each meter is also the same as 100 centimeters. And so the volume could be expressed as 100 centimeters multiplied by 100 centimeters multiplied by 100 centimeters. And that would give me 1,000,000 cubic centimeters. And so 1 cubic meter is the same as 1 million cubic centimeters. My conversion factors are complete. I can multiply the fractions. And I will end up with 1,320,000 grams over 1 million cubic centimeters. That will give me 1.3 0.32 grams per cubic centimeter. I can now calculate the mass of my chocolate block by multiplying its density, 1.32 grams per cubic centimeter, by the volume it occupies, 217 cubic centimeters. And that will give me 286.44 grams. I'm going to round this to 3 significant figures, and so I will have 286 grams. In summary, take care when dealing with square and cubic units. In such cases, the values of the prefixes do not tell the full story. We need to take into account that we are dealing with 2-dimensional and 3-dimensional objects. That is all for now, and I will see you on the flip side.